Hey everybody, Mr. Bells here again. This will zoom in the right way. This is a geometry video. This is for Geo A, section 5-6. We're still doing triangle congruence. Should be pretty quick through here, trying to add a couple more things to us. So far, again, we know that SSS works and SAS works, and something called HL, so hypotenuse and a leg. So that's a side-side angle situation, but it's got to be a right angle. So here we go. Here's our next set of things that work for us or don't work for us. Let me lock this in for you. Camera's slightly moving on me here. So the two new things that we got right here, again, this is in your Big Ideas Math workbook, page 150, is that these two things also prove it. So remember, we have SSS, we have SAS, we have something called HL, and all of those things help prove triangles are congruent. Well, we got two new ones coming to you right now. This first one says angle side angle. So again, that's two A's with an S in the middle. So if you see it on the picture, that's two A's with an S in the middle. Two A's with an S in the middle. So yes, ASA works. And then this one down here, angle, angle, side. Angle, angle, side works. So that means if I have an angle, and then the side marked, an angle, and then the side marked, we know that that's good enough to be able to prove it. So let's take a look at some markings on two different triangles, knowing that we have five things right now, right? SSS, SAS, HL, ASA, and AAS. So I got this triangle situation down here. Sorry about this. This just keeps spinning on me, and unfortunately, I don't have, this should help. Tighten up the camera for this thing. And I don't have any fingernails to be able to do it. Okay, so if I have markings like this, and I put an angle right there, that would be a side angle side, because I have to go clockwise or counterclockwise. It doesn't matter what it is. And I can't skip one of the things, so I can't go this way and call this SAS, because if it did, it would have to be side, and then this angle would have to be marked, and this side would have to be marked. Okay, so this is an SAS because it goes like this. Now this one right here, this would be a side-side angle situation. That would be an SSA, and that's not one that we have yet. That one, we can't guarantee that it works. There's a special situation for that later, but right now that doesn't work. And if I had this, like this one, 1, 2, 3, this would be an AAA situation. But an AAA isn't one of the ones that works either yet, right? We have SSS, SAS, HL, ASA, and AAS. Those are the five that we have. Okay, so now let's look at some of these, some practice ones with some of these triangles, and see if we got some things that we know. So you can see on this one, I've got an angle, and a side. So single angle, double angle, side. And if I go for this triangle, single angle, double angle, side, yes, that would work for AAS. Over here, I got a double angle, side, single angle, and a double angle, side, single angle. So yes, this would work for ASA. Cool. Over here, we're talking about triangle JKL. That's this big one, right? JKL. And MLK, that's that big one right there. We're trying to see if those two things form it. So what are some of the things that we could do to be able to maybe help with this? Well, I know this is going to be a stretch here, but watch. I know that if this angle here is there, this bottom side, that's congruent, yes. I could also mark these angles right in here congruent, right? And if those angles are congruent, then with this little triangle in here, I can get angle side angle and angle side angle, which means these two little triangles are congruent. And if they're congruent, then their parts must be. So I could put 3 marks on this and 3 marks on this. And now I'm going to have those 3 marks and those 3 marks, which means these angles down here have to be congruent by the base angles theorem because it's an isosceles triangle. And now I've got an angle, angle, and a side. So yes, we can do it. We just got to get a lot of stuff on that one. And on this one, right angle, angle, side, right angle, angle, side. That works pretty easily on angle, angle, side. Okay. So here it says, decide whether you can use the given information to prove that triangle LMN is congruent to triangle PQR. So what I'm going to simply do, I don't have to be perfect on my things, but I'm going to put LMN and PQR. I'm just going to draw a triangle, and then I'm going to write some things that make it true. So M is congruent to Q, so that means that, and N is congruent to R, N is congruent to R, that's true. And then it says NL is congruent to RP. So NL is congruent to RP. Awesome. So in this case I have angle, angle, side, angle, angle, side. Yes, I can, with that one, prove that those two things are congruent. So that's what I want you to do. I want you to go ahead and draw this one out the same way I just did this. So stop the video for a second. Draw the pictures out and decide whether or not that's true. Is there enough information to prove that the triangles are congruent? Okay, hopefully you've stopped the video and you're back now. So I'm going to try and do it again. So let's do my LMN, LMN, and PQR. So it says L is congruent to R, L is congruent to R, and I already know that's kind of not matching up, right? First letter to last letter. So like, ooh, M is congruent to Q, M is congruent to Q, and this says LM is congruent to PQ. Okay, so in this case, we know that I've got 2 angles and a side in between it. So this is an angle, side, angle situation. And this one is an angle, angle, side situation. And those two are not the same thing. So this would be a no. That's not enough to guarantee that these shapes are. Okay? Now, I could do this. I could say, hey, this angle right here has to be congruent to this angle right here because of the third angles theorem. But now you'll even see I can't do angle, side, angle because this angle, side, angle is 2 curves, side, 3 curves, and this one is 2 curves, side, 1 curve. So it's not corresponding parts that match up. Okay, so that's section 5-6. You'll see some other ones in here, some formal proofs. So I'm going to kind of just walk you through one of these things. It says that ray AC or segment AC bisects angle DAB and DCB. So if it bisects angle DAB, this one, that means that this angle is congruent to this angle by definition of an angle bisector. If it also bisects angle DCB, that means that that angle is congruent to that angle. And if that's true, we know that AC is congruent to itself by the reflexive property, and now the triangles are congruent by angle, side, angle, angle, side, and an angle mark. So hopefully you follow some of that reasoning, that justification, that makes sense. Okay, this one says prove that the triangles are congruent using angle, angle, side. So let's see if this works out for us here. See if we can, see if we can. It says O is the center of the circle, and angle N is congruent to angle P. So that angle is congruent to that angle right there. Let's see if these are true. So since you have the reflexive, or not reflexive property, but definition of a circle, this side right here is congruent to this side right here, is congruent to this side right here, is congruent to this side right here. And now if I cover that up, you can see, hey, this is an isosceles triangle. So if that's a single mark, then that's a single mark. And this one over here, that's an isosceles triangle. So if that's a single mark, then that's a single mark. And now we can use angle, angle, side, to prove that those two triangles are congruent. Okay? So as of right now, here's our summary after 5, 6. We have SSS, we have SAS, we have ASA, we have AAS, and we have something called HL. All 5 of those things help us prove that the triangles are congruent to each other. These are all shortcuts. And you know, once we prove those triangles are congruent, once we make that statement, triangle, like this one down here, triangle MNO is congruent to triangle PQO. Once we have those statements that are true, then we can say any of their missing parts are also congruent. Once the triangles are, then all 6 parts are, so all 3 angles and all 3 sides are. And hopefully that's beneficial to you. Okay, again, I said it was going to be pretty quick. That's section 5-6 on triangle congruent shortcuts. We'll talk to you later.